In this video, we're going to review some things that we've already learned about t-distributions in anticipation of using them for doing t-test and t-intervals. So we remember that the student's t-distribution is if the distribution of sample means is approximately normal, then the distribution of the following statistic has what's called a student's t-distribution. So the statistic is just like you would do for a z-statistic for a z-test. And that is, you take x bar minus mu over the standard deviation divided by square root of n, but this time instead of using sigma, you use s here, because remember s is the standard deviation of your sample, sigma is the standard deviation of the population. So if you do this, you get a sort of a standardized version of the distribution of x bar values, but it doesn't quite follow a normal distribution. It follows what's called a student's t-distributions. So these t-distributions are actually a family of distributions very similar to the standard normal distribution, also known as the z-distribution. There's one distribution for each degree of freedom. And n minus 1, where n is the sample size, is what we call the degrees of freedom. It's bell-shaped, very similar to a standard normal, and it has the mean, the median, the mode, all equal 0. Their standard deviations are always greater than 1, but they approach 1 as n increases. The larger the n is, the smaller the standard deviation, and the closer it gets to a standard normal. There are T-PDF, T-CDF, and inverse T functions all available in the TI-84 and the Inspire. This particular distribution was developed by W.S. Gossett. He was publishing under the name Student to work with small samples at the Guinness Brewing Company. Guinness didn't want him to put his stuff out there as an employee of Guinness, so he published his academic work under the name Student, under the pseudonym. So here's what the PDF looks like. I generated these graphs in the program Minitab, which is a statistical program. And here I have degrees of freedom 1, 2, 3, and 4. So in other words, sample sizes of 2, 3, 4, and 5. And you can see they all look very similar. They're centered up, mounted up, bell-shaped, centered at 0. And you can see that as the degrees of freedom gets larger, the standard deviation gets smaller. It gets a little bit taller and narrower here. Here is a degrees of freedom 5 student's t-distribution graphed along with the standard normal distribution. The standard normal is in black, the student's t is in red, and you see that it's a little wider and shorter and fatter a little bit than the normal, but not much different. So the same basic shape. So this is basically a variation on the normal. Is one way to think of that. Here is where t is has degrees of 15 degrees of freedom. It's closer to the normal. And here's one with 31 degrees of freedom. It's extremely close to the normal there. So let's review a few things with our graphing calculators. Use your graphing calculator to graph the t-distribution for a sample size of 10. Go ahead and do that, and then come back and check your work against what I have here. Press pause now. Okay, well, we're back here. The way you do that is you do T-PDF of x comma 9, because there are 9 degrees of freedom. Sample size of 10 is 9 degrees of freedom. And you get T-PDF from distributions. So you press that, you get x9. Here I used a window from -5 to 5 and -0.1 to 0.5 on the y's, and there's our graph. Use your graphing calculator to graph the t-distribution CDF for a sample size of 10, and this time we're going to use a -100 as an approximation for negative infinity. Technically, you should be putting in negative infinity, but there's not enough past -100 to the left to be showing up on our digits in the calculator, so let's use that in place of -100. So once again, go ahead and do this, and come back when you're done. Press pause now. So the way you do this is you do T-CDF from -100 to x, 9. And this works exactly like this would have been normal CDF. Same thing. And the graph looks pretty similar to a normal CDF as well. This time I use the same window here, except that I put the top of it up to 1.1. So I could see all the way up to where this asymptote happens at 1 here. So as all CDFs, it starts at 0 and goes up to 1. In this case, asymptotes on both ends. It actually crosses the axis right here on the y-axis at 0.5 because half the area is to the left and half is to the right. Half the probability is on each side. All right, here's the the same thing on a TI Inspire. So I graph both of them at once here. Sample size of 10 means a degrees of freedom is 9. So F1 is T-PDF X9. F2 is T-CDF negative 100 X9, just like the other one. And here I use the window. Here I use a slightly different window from negative 6 to 6 and negative 0.1 to 1.1, and clicked OK there. And of course I have a nice color software on my computer and nice color graph here. So this one's a little bit nicer looking graph. Now actually you see this extra little thing right here. Actually what I did is I put a slider here where I can actually click on this and type in a number. I can also click on these things and make this move up and down. Let me actually show you that. So over here on the right you see the T-CDF, and we could do the T-PDF by going to second variables for distribution. T-PDF is number 5. X value is going to be variable X, degrees of freedom was 9, and paste that in there and then graph it, and we'll see the little bell-shaped curve down here for the PDF, and the CDF's already graphed up there. Over here I graphed, so now let's take our attention at the Inspire over here on this side, and you see I've graphed 4 things right here. The black one is the F3, which is a normal PDF, X, 0, 1 is a standard normal, and the corresponding CDF for that is this pink one up here. And then in red you see the CDF for a T, and in blue you see the CDF for a T, the PDF for a T. And right now N is 2. And I can click on this to make N is 3, 4, 5, 6, and you can see this working. And so you see that as you get smaller, the lowest you can get is 2. You have to have a sample size of at least 2 for this to work. Degrees of freedom has to be at least 1. And we see that this is shorter and fatter than the normal curve, and you can see that it's a little bit, the red and the pink are off a little bit on the CDFs as well. As I let the N get bigger, we see that the blue curve approaches the black one and the red one approaches the pink, so the T is approaching the normal, both in the CDF and the PDF. And we get up here, you know, like around 30 or so, and which is the highest I set to my slider. You really can't tell them apart by looking at the picture here. I can also go right in here and change this back to like 6 or something like that. Well, I think I can. Yeah, there we go. So it's kind of neat. You can see that dynamically there with the TI Inspire. So the TI Inspire is an extremely powerful calculator, and you can do lots of cool stuff with it. So here are several different screenshots from what we just saw, with sample sizes of 2, 3, 4, 6, and 10, and you see that the T-CDF is approaching the Z-CDF, and the T-PDF is approaching the Z-PDF, Z being the standard normal. Let's do some computations. Okay, and to have one, just have the questions on there. But go ahead and do these computations on your calculator. The probability that T is between -2 and 2, T is less than -2.95, T is greater than 3.46, T is less than C, where C is 0.06, find C, and T greater than 0.02, find C. Okay, so here are the problems without the solution. So go ahead and pause the screen here, do these on your own, and then come back and check. Okay, so once again, here are the solutions on a TI-84. Well, I'll show you. Let's see. So here we want to do the probability that t is between -2 and 2. It works exactly like the normal stuff that we done earlier. Go to distribution. To do probabilities, you want the CDF. So T-CDF, that's number 6. Lower is -2. Upper is 2. Degrees of freedom were 9 in this one. And paste. Boom. There is the answer. If you want to go, let me just do second entry. Go back here. If we want to go from, I can do -100 to -2.95. 9 degrees of freedom is for the second problem, and so forth. For the inverse problem, this one has a built-in inverse t, so number 4. And the area we put in, the area means the probability or area under the PDF curve to the left. So that's there, and degrees of freedom again was 9. And this works out. If you've got an older system, you may not have had that previous screen. You may have to just type these, remember the order, and type these in. On the TI Nspire CX, here you can see everything worked out on there as well. And the way this works is you go to menu, probability, let's see, statistics, distributions, and you can find the t's here. So again, T-CDF, this one I can go from -infinity to say the -2.95. That was one of our problems. Degrees of freedom is 9. Okay, and it gives me even more digits than the other calculator did, but we did that. And an inverse trig is, inverse t is very similar. Go to statistics, go to distributions. Inverse t is there. The area means to the left, so let's do the last one. It's 0.02 to the right, which means it's 1 minus that, or 0.98 to the left. And again, 9 degrees of freedom. Okay, and there it is. So there are the screens for the TI-84, and here's the screen you can see for the TI Nspire. Okay, so if we have a real-world problem like this, a machine fills cups with coffee, the sample size 20 is taken, we find the average amount filled in the sample is 8.05 fluid ounces, sample standard deviation, the sample is 0.1 fluid ounces. A dot plot of the data suggests that the individuals are distributed fairly close to normal distribution. Describe the distribution of sample means. Well, since the individuals are nearly normal, the sample means are approximately nearly normal, especially with the sample size of 20. That's pretty big, so it's going to be good there. And the distribution of sample means has the same mean as the population, but has a smaller standard deviation. And so, since we don't know the population standard deviation, we can do a distribution of t statistics by doing x bar minus mu over s divided by square root of n. In our case, that is x bar minus 8. Now, if we suppose it's supposed to distribute 8 fluid ounces of coffee, that's supposedly supposed to be the mean. So if we were going to set this up for a hypothesis test, for example, we would assume that they're telling us the truth, that 8 is the mean, mu, so that'd be x bar minus 8. We'd have to use the sample standard deviation of 0.1 here, the sample size of 20 here. This turns out to, since the sample size is 20, has 19 degrees of freedom, because the one way to think of it is the n minus 1 in the formula for S. And so that's 19 degrees of freedom. So this is approximated by, or this is distributed by T-distribution with 19 degrees of freedom. And then we would use that information to go ahead and calculate things like T-intervals and T-tests. So in this case, we might be looking for a T-test here. Okay, so we'll see how to put this in work in our next video when we look at some T-intervals.